Hello friends, welcome back to my channel. In today's video, we're going to look at how to build a CI/CD pipeline using GitLab. So we will have our code in GitLab repository, and then we will set up an EC2 instance to use as our GitLab runner. From there, we will use NPM to build our code and install dependencies. And then we will use SonarCloud to perform our code analysis. From there, we will use Docker to build a Docker image out of our application. And then we will use Trivy Scan to scan our Docker image for any vulnerabilities. After that, we will push our Docker image to Amazon ECR and then deploy it onto Amazon ECS using AWS Fargate. Now, in order to access our application on a web browser, we'll attach an Amazon application load balancer to our application. Okay, so this is a complete pipeline project on GitLab. So please like, comment, and subscribe to my channel, and stay tuned for the entire project. Leave any comments that you may have in the comment section below. Let's get into it. So we have our code in our GitLab repository called complete CI/CD 02. I've cloned it to my local terminal. So if I do ls, these are the contents of the same repository. Before we start our pipeline, we need to set up a runner. Now, I don't want to use the shared runner that's provided by GitLab. We want to create our own VM and use that as our runner. And to do that, I will create an EC2 instance. Before I do the EC2 instance creation, let's go to IAM. I have a couple of user accounts here. I'll create a new one for this job. So create user. This user, I'll call it GitLab. Next, in order to make things easier, I'll just give it administrator access. Next, create user. So the user is created, GitLab, this is it. Go inside of it and now create the keys. Click this. You're using command line, so CLI. Confirm. Next. You need a tag. Create access key. Okay, so it's created. Now download this .csv file with your access and secret access keys. So it's downloaded here. On your local machine, open the CSV file you just downloaded and use it to configure your CLI. So on my terminal, I'll do AWS configure. I already had the user configured already. I will get rid of this and use my GitLab user. Select the access key ID in the file you just downloaded, the CSV file. Do same for the secret access key. Copy it and paste it here. Press enter. And the region, I will use the same region, US East 1. I will keep the default output as JSON, so just press enter. Our AWS user, GitLab, has been set up from our terminal, so everything looks good. Let's clear the screen. With that out of the way, let's go to the EC2 instance and then launch an instance. And I'll call this GitLab underscore runner. I'll use Ubuntu. And for the server type, I'll leave it as 24.04 long-term support. And for the instance type, because we are building a whole CI/CD pipeline, you need an instance that is quite capable of all the jobs that you would want to build. So let's use T2 large. Select that. Key pair. I don't have a key pair yet, so we will create a new key pair, and the name will be GitLab key pair. It's a PEM file. Create key, and once you hit create, it will download it automatically, and it's selected here automatically. If it's not, you click this and select it. The networking and everything, we keep it as default. Allows traffic from SSH port 22. And for the storage, let's make it about 30 gig. Launch instance. Instance is launched. Take a few seconds to come up, so I'll pause the video and wait till it's ready. Our instance is ready. All right, so the next thing is to connect to this EC2 instance. So if you select it, you should see all the information on it down here. I don't want to use this terminal to connect to the SSH, so I'll launch a new terminal. So this will be the terminal that we will use to SSH into the machine. To make it a little bigger, press the downloader key paste in the downloads directory. So cd into that. And then we are going to connect to our VM using the public IP address. This is it. Copy it. If you don't know the commands for connecting, you can select the runner and hit connect. And you see how to connect it. If you want to use SSH, we use this command to log into our server. First, you use the SSH-I, and then this is the name that we gave the keeper. And the user is Ubuntu. On our EC2 instance, select the runner, click connect. You see that the user here is Ubuntu. And then you can either use the DNS or the public IP address of your instance. In my case, I'm using the public IP address. So with this command, you press enter. And we are in our server. Let's clear the screen. And of course, the first thing you want to do is sudo apt-get update. Press enter. So our system is up to date. Let's clear the screen. And now we can go back to GitLab. Go to settings. Go to CI/CD. And then you can see runners. Click on this runners. These are the shared runners that GitLab already comes with on the right side. Okay, and there's several of them. Of course, you can use them, but I don't want to use them on this project since I need to upload my credit card. So that's why we are creating our own runner. So click new project. For the tag, let's call it GitLab EC2 _ runner. In our pipeline, if you don't tag a specific runner to a job or a specific stage, we want this runner to still run it anyway. So you can select this, okay? And then you have some configuration options here. If you want to pick, you can do that, timeout and all that kind of stuff. But I'll keep it as default for now. Create runner. Our instance is Ubuntu, so it's Linux. It's already selected. And you can clearly see you can use Mac, Windows, Cloud instance, Docker, Kubernetes, and so forth. We need a Linux, so it's selected. Step 1, here is command to register the runner. But before we do that, we have to install the GitLab runner itself on our server. That's what it says here. You have to install before we register. So click on it. Okay, so it's open on this side. You're going to use AMD64. And these are the commands to install GitLab runners on a Linux system. Hit this command to copy everything. This is our server. So I'll paste all the commands here and press enter. All right, so the runner has been installed. Let's clear the screen now. So after it's installed, you can close this. Next step is to register it. The registration, you need to copy this command. By the way, this is the authentication token for this runner. You can copy it and save it somewhere safe. So over here, paste the register command, press enter. So we are asked to enter the GitLab instance URL. I will just use the GitLab address. You see that is valid. Enter a name for the runner. Now this is stored only in the local config.toml file. Let's call this self-hosted 01. Enter an executor. You have Parallels, Docker, custom SSH, Docker plus machine, Kubernetes. There's so many executors here, so it's up to you really. But I prefer to use shell, because shell, you're able to do almost anything. So we select shell. Our configuration that we've given so far, including the authentication, has been saved at this location. If you go back to this page, of course, the step 2 is where we selected this shell as our executor. So this is done. And before we exit, I'll copy this authentication and paste it somewhere safe before we lose it. Next is step 3, where we will start running the GitLab runner that we just installed. Okay, so copy this command. And on our terminal, let's clear the screen. Paste this here. Press enter. Our runner started running in user mode. If you go back to our GitLab, you should see this message here. Okay, that we've successfully registered a new runner. And our runner is online and it's ready for jobs. If you go to view runners, you should see our runner right here. And if you want to remove it, you just use this button and that would remove your runner from GitLab. Okay, now at this point, we are gonna create our pipeline script. And so I'll be working from my local host where the files are. This is also the same place that I cloned the repository. Use touch to create the file .gitlab ci.yml. The pipeline code has to have exactly this name. Okay, .gitlab-ci.yaml in your repository. Create it, but you won't see it here because it's a dot file or a hidden file. So you do ls/la. This is it. All right. vi to that file, and then we will modify this from there. If you want to write CI/CD pipeline, you need to specify stages. You have some stages under it like this. So take, for instance, we want to install NPM dependencies. That will be a stage. And then the job itself, let's call this a build job. Okay. Under it, it will have a stage. And this stage will have this exact same name. So copy this, paste it here for the stage. And then you have tags. The tags, name of the instance, go to the runner, CI/CD runners. This is our CI/CD. This is the tag that we gave it. We called it GitLab EC2 runner. So copy that, paste it here. Script. So we run some commands here. Since we want to install NPM dependencies, NPM install. You can save this file now. Now this means the GitLab runner is taking jobs. Now this should keep on running in the background. Now because this has to keep running, I'll keep it as it is. And I will use another terminal. Choose a different color. Some solid color. That's a white one. Let's cd to the location of the PEM file, which is downloads. Then I will use SSH-I, and the key pair is GitLab _ key pair, and the username is Ubuntu. At the IP address. This is the public IP address. Copy that. Paste it here. Press enter. Okay. So we are in the server twice. This is monitoring the GitLab running jobs. And we can use this to install our Node.js. So on your browser, and Google install Node.js Ubuntu. Our instance is an Ubuntu instance. You can use the DigitalOcean link here. Okay, you can use apt to install it. So it's a very simple command here. This will update it, but we've already updated our server, so we don't really need that. So let's copy this command here. By the way, of course, you can run it here, or you can add it to the pipeline. If you want to add it to the pipeline, go to your pipeline script like this. And then at the stage where you have script, just add the command here before you run npm install. Now this is going to install Node.js. I need to install npm as well, which you will also find down here. Copy this. Paste that there. So we need to add -y for the installation commands. Right, so it started. Click on it, and you should see a pipeline job here. And you can see the whole process of installation, everything will be going on in the background. So our job did pass here. So that is how you would use GitLab to run your npm build command. Now at this stage, we will look at how to analyze our code using SonarCloud. So first, just go to your SonarCloud account. I already have one, sonarcloud.io. That should take you to the page. Log in. You can easily log in with our GitLab account. So let's use GitLab. And you see the accounts that we have on GitLab is up here. Authorize SonarCloud. SonarCloud does not support more than one DevOps platform at a time. So because I have the same email address that I'm using to sign up for that, I have to switch to my account for GitLab. This one is for GitHub. Let's continue. This will redirect us. Create a project manually. Create a project. Create a project manually. You need to create an organization first. So create an organization, and I'm importing from GitLab. So click GitLab, import my personal GitLab group. Now we need personal access token to create this. Click this to create a new personal access token. By the way, that would open access token on GitLab. I already have one that I created in the past. Click add token. Call this GitLab Sonar token. I'm gonna select some scopes here. Create personal access token. This is a token. Copy it and save it somewhere safe. In our Sonar account, you need to paste the access token here. then continue. And that will import the organization into your Sonar account. And this is the name. That is the key. By the way, if you go to the GitLab account, that is our organization icon. That's what you see right there. And so we will go with the free plan. Select free. Create organization. So this is our organization selected. Now we can create a project. We need a display name. So let's call this GitLab CI/CD. And that is our project key. This is public. Next. And at any moment, if the code changes, we will want to rerun our analysis. So select previous version, create project. Project is being created. And so now we have to link it with our platform, which is GitLab. With GitLab CI/CD pipeline, it's already here. You don't have to set it up manually. So click on this. Now you have all the instructions that you need to use right here. So first is add environment variables. The first one is sonar_token. So in GitLab, you just go to settings, CI/CD variables, and then you add the token. Let's copy this. And in our GitLab account, go to settings, CI/CD. Variables. This is right here. Then add variables right here. Key is the name. And the value of the token is this. Copy that. And paste it for the value. Now back here, it says make sure the project variable checkbox is unticked. So project variable here, untick it. Then the last one is make sure the mask variable checkbox is ticked. So it's a tick masked. Okay. Add variable. So that is added. Okay, next. So you pretty much have all the instructions here. There isn't much to do. Just follow the instructions carefully. You're gonna add one more variable, which is SonarHost URL. So I'll copy this. Add another variable. SonarHost URL. And the value for that is this Sonar web page. Paste it here for the value. And we do the same thing. You will uncheck the protect variable checkbox and the mask variable will be checked. The same thing here, uncheck this and check that. Add variable. Now next is step 2. Create a CI/CD YAML file. We've already created that. Our code is Node.js, so select other. You see JS here. This is already created, so we will just copy this and add it to our script. So copy. This is SonarCloud analysis. Now I'll call this job SonarCloud Scan. And then the stage SonarCloud analysis. So the command that we copied here is basically gonna do our installation and the run commands, okay? And as you can see, it uses a Docker image. Copy this. Paste it in here. Now I'm gonna clean it up a little bit. First, we need a stage inside the step that we copied. I'll paste the stage here. Now, over here, we have variables. Now, these are environment variables. I'll copy this. Then I'll get rid of all that. Now, this has been merged to our code, so this is okay. And then I will separate the environment variables up here. Okay. This will be all our environment variables. We basically have two stages. We have some environment variables. We have our build job. Then we have our SonarCloud job right here. All right, now back on our pipeline, you see that the branch that we are working on is the main branch. This is what is going to trigger it, cause merge requests, but we don't have master branch, so this should be main branch. We don't have developer branch. Just get rid of this. You don't need it. Now, next thing, you can see that over here, GitLab is going to pull the Sonar scanner Docker image, but we haven't installed Docker on our system. So Docker installation has to be installed on our system for this command actually to work. And for that matter, for the whole of this to actually work. Instead of going into the server to install it manually, I will add it to our step here. The commands to install Docker. Sudo apt install docker.io. Of course, yes to all prompts. Then I want to attach permissions for user and group. That is for to be able to run the Docker socket. Okay. Now, before we commit the changes, let's make sure that everything is catered up for here. This is the second stage. Okay, so we have a third stage. This one is done. We need to create a Sonar project.properties file. Okay, and add this content to it. So I'll copy this. And then I'll save our script as it stands. If I do ls, this is the current content. So I'll create the file. The file name should be, let's copy this. Come back and copy the Sonar project.properties. VI into it. And then the content is going to be this stuff. Copy it. Paste it in here. All of this stuff are already committed out, so you can delete it. The main thing is this part. Save it. And now we've added many changes. So git add, git commit, then git push. Let's go to our GitLab account. So it started running. And this is our second stage. By the way, you would see that the runner has also started. So the build job is done. And now the SonarCloud analysis. Okay, so that also was a success. So let's go back to our SonarCloud account. Now we can get out of here, right? We don't really need this anymore. Okay, let's go to my projects. This is the project. The branch is not master. It's main. So click branches, main, and you see that the scan did pass the quality gate check. All right. So this is how you would integrate SonarCloud with your GitLab CI/CD pipeline. All right. And of course, on the pipeline, if you click this, you will see all the analysis that was going on. Everything is in here. Right. And everything was executed successfully. It took roughly 37 seconds. Now, the time that it takes to execute a job is going to depend on the type of VM that you attached to your GitLab CI/CD as a runner. So our next step is to build our Docker image for our application. Now, to do that, in our repository, we already have a Docker file here. It's a simple Docker file. It's going to use the node Alpine as our base image. We'll set /app as a working directory. And then we'll copy the package files into the container. And then we'll run npm install only production. This is going to help to not make our Docker image be too big or bloated. When you run just this, it has both production and development dependencies that we don't really need. We're only opting for the production side. And then we'll copy everything else, which is basically the application. And we will expose our application on port 3000. And this command would start our application. So very simple Docker file. We'll edit our pipeline script from the terminal. I'm going to add one more stage, and this will be Docker_build. Scroll down, Docker build job, and then the stage name is what we put here, which is Docker build. Let's copy it and paste it here. The script, we installed Docker here, so it's already installed, so we don't need to do installation for Docker. We can go ahead and build our image. So Docker build -t, let's call it repo name, colon, and I'm going to use the tag CI_commit_sha dot. Now this is a random hash that GitLab is going to generate. We are not pushing our image yet, so I will change this later. For now, let's assume this is the name of our Docker image. Save this. Then push our changes to GitLab. So let's go to our pipeline, refresh this. Let's see our pipeline here. All right, so that's our new stage we just added. So we have an error. Let's check what the error is. So there seems to be a problem with our Docker installation. On our other terminal, let's do Docker version. Good. Let's do sudo apt update. Since Docker is installed, next command I will run is sudo usermod -ag Docker GitLab runner. Now this is going to allow GitLab runner user to run Docker commands without having to use sudo. And it does that by adding the runner to the Docker group. Okay. So press enter. But after this, we have to do a restart of Docker. So sudo systemctl restart Docker. So if you do sudo systemctl status Docker, it's active and running. Control C to exit. What I will do is I'll go to the other terminal where the GitLab runner is running. I'll exit this. And then I'll restart the GitLab runner. Restart. This will restart our runner. And so now let's start the GitLab runner one more time. So now it's available to run jobs. And our Docker is updated. If you push our pipeline script one more time without making much changes, it's basically the same thing. Docker installation here. You have the SonarCloud. And then here you have the Docker build. Of course, we can add more stuff here, especially like the branch. We can also add the tag for our runner, even though it picks it up automatically. You can still add this to all of them. All right. Let's add the branch, its main. Then we are going to save this. Git add, git commit, git push. And let's go to GitLab. Our pipeline jobs. You see it started. So our build job is done. If you go in there, you should see the commands that we ran. You can see it was running each line in the Docker file that we saw earlier. It's built successfully and tagged it as the repo name with the random hash from GitLab CI/CD. Now when we go to our VM for the EC2 instance we are using as our runner for Docker images, you should see this is the node Alpine that it's pulled for the Docker file. And this is the actual Docker image that we built from this stage. At this point, we are going to use Trivy to scan our Docker image. So let's go to our pipeline script. This is our pipeline script. So I'm going to add a stage. This will be for Trivy scan. Then I will scroll down, but let's copy this before we forget so that we will add it to the scan job. Go down after your build and add image scan job, and then the stage name is the name that we copied from above. Script. For Trivy scan, I'm going to use the Trivy Docker container to do the scan. So I'll keep this as empty for now, and then I'll fill in the rest. Of course, we are only running on the main branch, and the tag is still the same GitLab runner that we created using EC2 instance. Okay, now let's get a command for that. Before we go, I will just save this. Go to your browser and search for Trivy. This is the Trivy installation home. The documentations. and go to installation. And when you go to installation, there are several ways you can install Trivy and use it. So many ways. I want to use a container, so I'll use the container instance here. So the process is basically to pull the image, and then you have to mount a consistent cache for Trivy. Now, if you don't do this, the Trivy will run properly or correctly for a couple of times, but then after that, it would say that it's unable to download the vulnerability database. So this is very important. And then we will mount the Docker socket on the server to that of the container for Trivy. So this is an example command that we can use. This is just Docker run. This is the mounting of the Docker socket from our VM to the container. And then this is the mount of a location where we are going to store the cache for the vulnerability database from Trivy, okay, which is very important. This is a Trivy image that we're using, and then this is the image that we are scanning. Copy this and modify it in my script. So that is copied. I'll paste it here. Then I'm gonna modify it a little bit. First off, the image is supposed to be this image we have here. Copy and paste it here. So the only thing that I'm changing is the image that we are trying to scan. We can save changes, and then let's push changes to GitLab. This Trivy scan, then git push. All right, let's go to our pipeline script. Refresh this, and our pipeline should start. So let's go in there. Okay, so you can see it's successful. Click this, and you should see the results of our scan. You see 1 low, 0 medium, 0 high, 0 critical. You would see that for the Sonar analysis, you see a warning on it. So at the moment, Sonar, when you run it too many times, it would fail automatically at some point. Okay, when you run the Sonar scanner too many times, it will fail a number of times. So you have to add to your code that in case there is a failure, the pipeline should still run, right? And so that's why, even though it failed, there's a warning on it, but then we are able to build our Docker image and the Trivy scan. And to do that, in our pipeline, if you check the pipeline script, I added a 1 line in there that is creating that. So this is it. So when it's successful, it will build. When it's gonna fail, it will allow the pipeline to keep on going. So at this stage that our image is ready and scanned, we are going to push our Docker image to Amazon ECR. Let's go to our pipeline script. It's already loaded. Then I'm going to add a new stage. Let's call it push to ECR, Amazon ECR. Need this, so let's copy this. And let's go down and add pipeline job. So our job name, let's call it push image to ECR. And the stage is what we copied, paste it here. So we need some scripts. We don't have the scripts yet, so let's add the extra details with the branch and the tags. Paste it here. Okay, so we're gonna fill in here with the scripts. So let's save this. Saved. Let's go to Amazon Management Console. This is EC2, so let's search for ECR. This is it. Let's open it in a new tab. All right, so this is it. Create repository, and I'll call the repository name GitLab CI/CD 00. Let's call it that name. Leave everything as default. Create. Okay, so this is our ECR repository. Go in there. So if you click on view push commands, you'll see all the commands that you actually need to push the image to the repository. So first, you will log in. Copy this. Paste it here. That is just for logging in. Next, you build the image, but we've already built the Docker image. So what I would do is I would just copy this name here and use that to replace the name of our image we built earlier. Let's go to the build step. It's up here. So this is Docker build. So I'm going to replace this whole thing with that. Next is to tag the image. So I'll copy this command here. And that is in the push section. Paste it here. By the way, I forgot something. I have to tag this as latest. And then we will tag GitLab CI/CD 00, which is exactly this. This is the new name of the Docker image. And I'm scanning the old name. So I need to replace this. Or just change this. Next, this is the push command. So copy this. Then paste it down here. Now, this is going to run AWS commands. So first thing you need to make sure of is AWS CLI is actually installed on our server. This is our Ubuntu server. And so on my browser, I would search for install AWS CLI on Ubuntu. And you see links from AWS right here. It's a Linux command, a Linux instance, and these are the commands. So just copy these commands here, run them on your Ubuntu server. Make sure that you have unzip also installed on your system. I've already installed it, but I will still run it anyways just to show. So you do this. Actually, before I run it, let's check if unzip is installed. So unzip help, so you can see unzip commands will work because it's already installed. Okay, then we can paste a command there and it will run all the way. Now you can see that it's trying to replace the one that I already installed earlier. So if you say yes or Y, and you can also use all or A for everything, should be capital A. That will do the whole thing all over again. Next then it says, please rerun install script with update flag. This is the install script. So we are going to do //update. That's done. So if you do AWS You see AWS is installed. You're getting commands from that. Now, before we push changes, I'm gonna clear the screen for server here. Let's do AWS configure. So our access key ID is not configured here. We can copy and paste them here to set up the GitLab user. The region we use US East 1. The default output. So AWS is configured. So if I do AWS configure again, you should see that the IDs are already in there. Let's quit this, clear the screen. Back here, we can add the changes to GitLab. Okay, done. All right, so our push was successful. You click this, you should see some information in there. The login was successful. Then the push did work. But before that, you did a tag and then the push. Let's go to our ECR registry. Let's close this, refresh, and we should see an image here, which is latest. That was the tag that we gave it. At this point, we want to deploy our image to Amazon Container Services, which is Amazon ECS. First, let's open that ECS. So this is a default cluster. I'm going to create a new cluster, create, and now call this icon ECS. And this will be our default namespace. Now it's going to be a Fargate instances that will be running. We don't want to manage our own EC2 instances. That will be the nodes of the cluster. So I'm using Fargate. Now there are some optional things here. I'll keep it as default. Encryption. You can use KMS to encrypt some keys if you want to. Keep it as default, and then you can add some tags to your cluster. All right, I will leave all these as defaults and hit create. Now this may take some time, so let it do the creation. It's already done. All right, so here's our cluster. At the moment, there's nothing going on in there. It's active, and that's about it. Next thing, go to task definitions, and we are going to create a new task definition. For the name, let's call it icon ECS task def. For the infrastructure, leave it at Fargate. It's going to be a Linux system. That will be the nodes of that cluster. 1 CPU, 3 gig memory. Now, instead of assigning the role, I'll assign an execution role. This is ECS task execution role that I created. If you want to create a role, just click create new role, and then you will give it execution of ECS tasks permissions. So I'll select that, and this is our first container. Gonna give it some name. Let's call it GitLab 00. And the repository URI, let's go to our ECR. This is the repository. and this is the URI. Copy this. By the way, we need to add the tag to it. So if you paste it, you have to add the tag latest. Essential container, let's leave it as yes. Next, port mapping. So we have port 80, but then in our application, this is our application. The app listens on port 3000. So we need to allow port 3000 as well. So I'm going to add another port mapping. That will be for port 3000. These are just resources. You want to add environment variables, you can do that here. This will collect the logs. This is our storage. I'll leave the rest as default. Create. So it's active. That is our task definition. Okay, let's go back to our cluster. This is the cluster that we are working on. Now we can add service to our cluster. Now, service is what's going to expose our cluster to the public internet. So create service. Equals ECS, that is the name we gave our cluster. Compute options, we use capacity provider. And we are still using Fargate to run our service latest. And this is of type service, of course. Now let's select our task definition. This is it. Service name, let's give it iQuant ECS SVC. Service type replica. Deployment options. This is rolling updates. You can select plugin deployment option. I'll keep it as default. Failure detection. You can do rollback. I will leave all that as default. Networking. Now for networking, I will keep everything as default here. It will create a new VPC. Assign some subnets in the VPC. This is the security group. Now let's create a new security group. And the name, we will call it ECS iQuant security group. And then for the ports, let's open port 80. And then I'll add one more. This will be for port 3000. Custom TCP. Now both of this from anywhere. And keep your public IP turned on. Next, load balancer. You want to access it on the browser, so you need a load balancer. And this is going to be an application load balancer. And our application listens on port 3000, so you're going to port 3000 to 3000. And then let's create our load balancer. I will call this iQuant ECS application load balancer. Now let's create listeners. So listeners, this is a default listener for HTTP protocol. And then for target group, this is going to be a new target group, and this is the name. Let's change this a bit. ECS iQuant target group. Protocol is HTTP and it's 300. And we are going to do a health check. Now for the health check, in our application, there's no page on our root directory, which is slash. So the application is currently only on /hello. So for health check to pass, you have to make it /hello. Now the rest, we have some optional auto-scaling commands, volumes, and tags. We'll keep it as default, create. And this will take a few minutes, so I'll pause the video for it to be ready. So our service is successfully deployed. And this is our cluster. If you scroll down, you should see services, and this is our service. And you can see it's active and it's currently running. If you go in there, you will see some more details about it. And more importantly, you will see that it's healthy. If it's healthy, then our application is accessible on our browser. Now, if you go to our EC2 dashboard, this is our EC2 dashboard. Scroll down here, go to target groups. This is the target group we created. Go to load balancer. This is our load balancer. This is also what we can use to access the application. Now, let's also check the security group. And this is our security group. And you can clearly see we have port 3000 and port 80 opened. Now, let's go to our pipeline script. Let's clear the screen here. Back to our pipeline script. I'm going to create a stage. At this stage will be deploy to Amazon ECS. Right, scroll down. And after the push, I'm going to create a new called deploy image to ECS. Stage. It's what we created up here. Let's copy it. Paste it here. Script. All right, first let's echo deploying to AWS ECS. Now, since our ECS deployment, we've already done it on AWS, what we will do is to update it. We run AWS ECS update service cluster, and the cluster name this is our cluster name, iQuant ECS. Service, the service name, you go inside it. This is our service name. Copy this. It's our service. Then we will force new deployment. Now, region. Our region is US. It's 1. You can also use environment variables for that. Let's save this. Save, push changes to GitLab. Let's go to our pipeline, refresh this. So you can see it successfully deploys to ECS. You open it. You should see the process of the deployment, everything in here. Because we created a service in the cluster earlier, you just update it and it will force it to redeploy it with the same settings that you gave it originally. So on our EC2 console, go to load balancers. Let's go inside it These are all the details. You see the DNS name here. Copy this. This is the A record. Go to your browser. Paste the link there and press enter. Of course, you get an error because we have no information on this home directory. So I have to do /hello. And you see, hello world, welcome to iQuant YouTube channel. And that is exactly the app.js. That's the message in our application. And this is the path it's on. That's why we did /hello with the load balancer. Now, before we go, let's do a cleanup. First, I'll remove the cluster. So delete cluster. Now, deleting a cluster will automatically delete the service as well. So delete. The service is deleted. Now it's deleting the cluster and the other stuff. It's impossible. Let's diagnose with Amazon Q. That's because it's associated with other AWS resources. That's why the deletion was impossible. So in this case, most of the time you have to delete the other resources before you can get rid of the cluster. The solution is to go to CloudFormation and then look for cluster, the cluster that we created. And then we are going to delete that from CloudFormation. So let's go to CloudFormation. Open it in a new tab. This is our stack and the delete field. Now the instruction is to select the stack and delete it. Once the delete is complete, you can go back to ECS, select it and delete the cluster. So selected it here. We try delete. Now we will delete the entire stack. So delete. All right, it's been deleted. Let's go to our ECS, close this, and now we can retry deletion. Nice, successful. Close this, so our cluster is gone. Our service is gone. Task definitions, actions, deregister it. Let's go to the load balancer, refresh this page. Okay. So you have the load balancer. It's currently active, selected. We can delete it. Confirm delete. That's gone. Target group. Select this. Delete. Yes. That's also gone. Security groups. This is our security group. Select this. Delete. And it's deleted. Now, don't also forget to terminate the instance that we used as our GitLab runner because it's still running. By the way, we use the T2 large. You can either stop this or terminate it. So stop or terminate this. Either one is fine. I'll just stop it for now. Click stop. And it's currently stopping. And you see that our runner has exited, okay, because it's not accessible anymore. And it says system will power off. So it stopped completely. Then our connection to the server is also lost. All right. Thank you for joining me on this video. Please like, comment, and subscribe to my channel for more videos like this.